Hello everyone, in this video I'm going to do two examples of finding equilibrium when there are two unknowns. So to get things started, I'm going to do a swing problem where we have a large swing being supported by two cables. The swing is going to have a width of 2 meters, and we have two cables pulling up. One here, we call that force A, and another one here, we call that force B. And on the swing, we're going to have a person, and we'll call this force P for person. And this swing also has weight, so we'll call that force S for the swing. And the swing will have a weight of 100 newtons, and the person will have a weight of 200 newtons. And one last little bit of information that we're going to need to do this problem is how far is the person from the end. Let's say that they're 0.5 meters. And the goal here is to find force A and force B. To do a problem like this, we cannot do forces up equal forces down because we have two unknowns for going up. So the first step of doing a problem like this is to use torque equilibrium. Torque clockwise equals torque counterclockwise. And to do this, we need to define a pivot point. And I'm going to choose my pivot point at force A. The problem-solving strategy is to place your imaginary pivot point at one of the unknowns. And then once you do that, try to find the torques due to each force around that imaginary pivot point. So force P will create a torque P that tries to make the beam go clockwise. And force S, S for swing, is going to try to create a torque S, which is also going to be clockwise. And force B is going to try to rotate the swing with a torque B that is counterclockwise. Once I've identified the torques, I can then go back to the equilibrium equation and expand this, make it more detailed. So my clockwise torques are 2 torque P plus torque S, and that equals torque B. And then I can expand even further, writing the basic definition for torque, which is torque equals R times F. So RP times FP equals RFS times FS, and that equals RB times FB. I'm solving this equation, next line down, for FB. So FB equals RP FP plus RS FS divided by RB. And now I'm going to plug in the numbers. RP is the distance from the pivot point to the person, so that's 0.5. FP is the weight of the person, so it's 200. Plus RS is the distance from the pivot point to the center of mass or center of gravity of the swing, which is 1 meter. It's half of the 2 meter length of this swing. And FS is 100 newtons, divided by RB, which is how far is it from the pivot point to the wire on the other side. That's 2. And let's see what we get for force B. So I believe it's 100 plus 100, and divided by 2. I think it's just 100. Yeah, it's 100. So that's 100 newtons. So there's our first answer. To find out what force A is, we could repeat this process, or we could just say forces up equal forces down, because this also must be true when there's equilibrium. Our two forces up, force A plus force B, and that has to equal force of the person plus force of the swing. When I solve for force A, I get FP plus FS minus FB, excuse me. And let's see what this is. 200 plus 100 minus 100. So force A equals 200 newtons. And there you have a simple example for finding equilibrium with two unknowns when there is cables. The second example I'm going to do is very similar, only the setup is different, because now instead of having cables, we're just going to have supporting columns, and we're going to need to find the compression force in each of those. The example says the compression force of column B, but we're going to do both. So these push up with a force. I'll call that force A. And this one pushes up. I'll call that force B. You can see the setup here. We have a 20-meter long bridge or roadway with a car, a truck, and a person. And the car is 1 meter from the left. The truck is 7 meters from the left. And the person is 2 meters from the right. And the supports are 3 meters in from each end. So I'm going to label my forces, which would be a good starting point. I'm going to label this one force for car, FC, C for car. I'll label the truck FT, T for truck. I'll label the bridge. I can't use FB because I already have that. I'll use FR, R for roadway, and then have FP for person. Again, just like the previous example, I'm going to use torque as a way to find equilibrium, especially since I have two unknowns. So torque clockwise equals torque counterclockwise. I'm going to make my pivot point at A. So we can draw that in. This is my imaginary pivot point, problem solving aid. And let me label my torques. Force C is going to try to make the bridge rotate around the pivot point with a torque called torque C, and that's going to be counterclockwise. The truck is going to create torque T, and that's clockwise. The roadway, torque R, and that's clockwise. The person, torque P, and that's clockwise. And then the column pushing up is going to create a torque B, that's counterclockwise. Excuse me. So now when I write all the torques together, group all my clockwise ones together, I'm going to get torque T plus torque R plus torque P equals torque C, C is counterclockwise, plus torque B. And now we're just going to continue solving this equation. We're going to write out what each torque is equal to. So RT FT plus RR FR plus R. That was a mistake there. That erased everything. RR FR plus RP FP equals RC FC plus RB FB. I'm going to solve this with force B. Force B equals RT FT plus RR FR plus RP FP minus RC FC divided by RB. So there's your solution for force B, and now I need to plug in the numbers. So let's see. I have to kind of go back and forth between the diagram and my equation. RT, how far is it from the pivot point to the truck? Well, the truck is 7 meters from the left end, but the pivot point is 3 meters from the left end. So 7 minus 3, it's only 4 meters from the pivot point. The truck has a weight of 3,000 newtons. The roadway is 20 meters wide, so the center of mass is 10 meters from the left edge, but the pivot point is 3 meters from the left edge. So 10 divided by 10 minus 3 is 7. The roadway is 10,000 newtons. The person is 2 meters from the right end, and the pivot point is 3 meters from the left end. So 20 minus 2 minus 3 is 15. They are 15 meters, and their weight is 200 minus the car. The car is 1 from the end, and the pivot is 3 from the end, so that makes them 2 from one another. So 2 meters times 1,000, I believe, is the weight of the car. And then the total distance from the pivot point to the other column is 20 minus 3 minus 3, or 20 minus 6, which is 14. And we're going to get force B. And let's see what that is. Let me do a quick calculation here. 4 times 3,000 plus 7 times 10,000 plus 15 times 200 minus 2 times 1,000 divided by 14, and I get this answer, which is 5928.57 newtons. If I want to do force A, I'm going to do forces up equal forces down. I could do the same torque process over again, choosing a different pivot point, but I'm going to do forces up equal forces down. So my up forces are 2, there's force A plus force B, and then I have all the forces down. So that's force on the car, plus the force on the truck, plus the force on the roadway, plus the force on the person. And force A equals force on the car, plus the force on the truck, plus the force on the roadway, plus the force on the person, minus force B. And I'm going to plug in the numbers. Force A equals 1,000 plus 3,000 for the truck, plus 10,000 for the roadway, plus 200 for the person, minus 5928.57. And let's see what we get for force A. 1,000 plus 3,000 plus 10,000 plus 200 minus. And we get this final answer. Force A equals 8271.43 newtons. So there you have it. There's how to do two different types of examples where you're finding equilibrium when there's two unknowns. Just keep in mind that you want to do torque clockwise equals torque counterclockwise first, identifying a pivot point. Best place to place the pivot point is at one of the unknown values, and once you do your torque clockwise equals torque counterclockwise to find one of the unknowns, then you can do forces up equal forces down to find the other unknown. So I hope that helped a little bit with those types of problems.